Alright, today we're going to talk about independent and dependent events, and your learning target is to be able to find the probability of each of those types of events. I hope that you find that independent events are going to be a lot like what we did yesterday. So remember, when we're doing probability, it's important to remember what we do for and what we do for or. Yesterday we did a lot of or situations, and that's where we are going to add the probabilities together. Today we're going to see more and situations where we're going to have to multiply them together. We want this and this to happen. So just remember what those mean. So let's jump into what independent events are. Independent events have no effect on one another, so they're outcomes that do not influence each other. So whatever you do first has no effect on what you do second. So an example of that would be rolling a die and flipping a coin. Whatever you get on the die has no effect whatsoever on what you're going to get on the coin. That's what we call them independent events. So I'm going to skip down to example number 2. Eventually you guys are going to try this one, but I'm going to show you this example first. So we want to figure out what's the probability of rolling an even number on the die and then flipping a tails on the coin. So remember, the even numbers are 2, 4, 6. So that means we have 3 even numbers out of a total of 6 options on the die. That's my probability of getting an even number. So then it says and, so that's a key to multiply, the probability of getting a tails. So if I flip this coin, there's 1 tail out of a total of 2 total choices on the die. So I've got my probability of the first event times the probability of the second event. So I'm going to multiply those together, multiply the tops, multiply the bottoms. Remember, for multiplication you do not have to find a common denominator. So we have 3 on the top and 12 on the bottom. And then remember, for probability we are always going to find the percentage. So when you divide the top and the bottom, you're going to get 0.25. And remember to change that to a percent, which would give you 25%. So not great chances, but not too bad either. You have a 25% chance of getting an even number and a tails. Okay, so I want you guys to pause the video and try to find the answer to this first example of independent events. Alright, now we're going to talk about dependent events. So independent had no effect on each other. Dependent events are going to affect each other. So the outcomes of a second event depend on what happens in the first event. So a big hint when you're trying to decide if something is an independent or a dependent event is this phrase down here. I want you guys to circle this. This is huge for dependent events. If you are doing 2 things, like you're picking 2 items out of a bag or 2 cards out of a deck of cards, and you don't replace that first card, that's going to be a dependent event, because whatever you get the first time affects what you're going to get on the second pick. Okay, so I'm going to have you guys try, actually I'm going to have you guys cross this one out. You guys don't have to do this. This is a review from yesterday. So we're going to jump right down to example number 2. So it wants us to find the probability of picking out 2 red M&Ms from this bag. So I know it doesn't say it, but what this means is it wants you to get a red and then another red. Okay, so I know it doesn't say and, but that's what it's asking us. What's the probability of picking out a red and then picking out another red? So let's find the probability of this first red. So we have 3 red M&Ms out of a total of 9 M&Ms. Alright, so I know it seems silly, but I'm going to actually draw this bag here. I'm going to draw our M&Ms. So we have 3 red M&Ms. We have 5 green. You guys can do this with me if you want. I'm a visual person, so sometimes this helps. Oh, bummer, I don't have orange, so I'm going to use yellow. Don't get confused. Sorry. Alright, so there's our bag, and it wants to know after I pick out this red, okay, I'm not going to take all 3 out, okay, I'm just picking 1 out at a time. So if I pick out one of those reds, so it's gone. I'm not going to put it back. It's now outside of the bag. Or maybe you ate it. You're going to figure out what is the probability now of getting another red. So let's count them up. We only have 2 reds left in the bag. And what is your total now? We only have 8 left in the bag. Okay? So that's the difference with dependent events. You're not going to put that first item back so it affects what you have left. So just like we did for independent, we're going to multiply the tops, multiply the bottoms. And then you're going to want to change that to a percent, which when you simplify, you're going to get 1 out of 12, sorry. And then you're going to calculate that percentage. Here. So you get 0.08, which changes to 8%. Okay, so I know that's kind of a lengthy problem. I'm going to just get this one started for you, and then you guys are going to try the rest on your own. So I'm going to go back to our example here. We're now going to put all of the M&Ms back into the bag. We're going to start fresh again. So it wants to know the probability of getting a red M&M. So again, we have 3 reds. I'm going to write it down here. 3 reds out of a total of 9. Okay, now it doesn't say and, but think of and then. So times getting a green. So we picked out one of those reds. So one of the reds is gone. It's outside of the bag. And now it wants to know what's the probability of getting a green. So we have 5 green, but what's different? We don't have 9 left in the bag anymore. We only have 8 left because we kept one of those reds outside. Alright, so I'd like you guys to calculate what that would be. What's the probability as a percentage? And then you're all set.